How do you multiply fractions? Top times top. So if you're doing 7 over 10 times 1 over 5, 7 times 1, 5 times 10, that's it. Okay? If I'm doing 9 over 10 times 5 over 6, a couple different ways you can do it. 9 times 5 is 45. 10 times 6 is 60. What do you always have to do with fractions? Reduce them, exactly. What goes into 45 and 60? 5. 5 goes into 45. 5 goes into 60. 12 times. Can you go lower than that? What goes into 9 and 12? 3, so it becomes 3 over 4. Okay, so you should always reduce the fractions. Now, that's how we would do it if we're dealing with numbers. But you can also think of it this way. 9 over 10 times 5 over 6. Whoa. What's 5 divided by 10? 1/2. What's 9 over 6? 3/2. How do you multiply 1/2 and 3/2? Okay. Now, nobody usually does it when you have numbers like that. Okay. But with rational expressions, that's how you want to think of it. Okay. So if I have 12xy over 4z times 3xz squared over y, all right? I look at this. I could go like this. I could go 12 and 3 is 36. X times x is x squared. Y times no y's is y. And there's a z squared over 4 times 1 zy. And then simplify it. 36 over 4 is 9. X squared. What happens to these y's? They go away. What happens to z squared over z? So I could do that. Or at this stage right here, I could go, oh, that z cancels that. This y cancels that. And I get there, and I could go 12 divided by 4 is what? 3. What's 3 times 3? Okay. So this is more work, but it's easier to see how stuff cancels. But you're going to see when we get into especially proper factors, it's usually easier to just cancel stuff at the first stage. Okay? I don't care how you do it. It's up to you. All right? What would the restrictions be on this one? Show you the original. There's the original. What would the restrictions be? What are the NPVs for this one? Z cannot equal 0 and y cannot equal 0, right? Because they're both in the denominator. Okay. Sorry? If you have two variables, you have to write the variable. But if it's just one variable, like the next one we're going to do, you can just write what they are. Okay, this is what you're going to see. So we have x plus 1 over x minus 2 times x plus 3 times 2 times x plus 3 over x times x minus 1. It's already in factored form. So when it's in factored form, write your NPVs right away. What are the NPVs? Go through. What makes this one 0? What makes this one 0? -1 and 0 because of that x there. So you have 4 NPVs, okay, or domain restrictions. Now, cancel everything. This x plus 1 here we'll cancel this x plus 1 there. So those are gone. This x plus 3, we'll cancel that x plus 3. What am I left with? What? What else? There's something else. A 2. 2 in the numerator and an x minus 2. Anything else in the denominator? The x right there. Is that 2 right there? Do not multiply this x in. Just leave it in factored form. Okay? And that's it. That question's done. All right, second one. It's not factored, so what do you need to do? Factor. Just like pretty much every question we do here. So, here we go. What can I do to this? 4x plus 16. You can only pull a 4 out. Can I do anything to the 2x minus 1? What can I do to the bottom one? 14x minus 7. 7. And the x plus 4 is already factored, so. Okay. Write your NPVs now. Negative 4 is one of them. What else? Which is it? Sure? Okay. 1/2. Anything else? Any other NPVs? No. All right. Cancel. What cancels? And there's the bottom has 2x plus 4s, right? So only one of them cancels, and the 2x minus 1 goes away. What's left in the numerator? What's left in the denominator? Do I multiply the 7 into the x plus 4? Just leave it and walk away. We okay? Yeah, but are you ever okay? All right, 380. We'll do this one. Give you a few questions. All right. Looks big and complex. It is not. What do we do every single time? What is your first step on every question like this? Factor, factor, factor. All right. What can I do to this? Sorry? Pull out a 2m squared. I'm left with m minus 2. What can I do to this? Think of it as this. Factor it, right? What multiplies to negative 6 and adds to negative 1? 2 and negative 3. Why am I changing them to x's now? M plus 2, m minus 3. All right, top's all factored. What can I do to the bottom? This one. 3m, and I get m minus 3. What's that? Oh, it's something. The difference of squares. M plus 2, m minus 2. Remember, you're allowed to have your factor sheet on the test. So you practice using that in class. Okay, it's all factored. So NPVs, what are they? Okay, there's one. And there's another one. And positive 2. Anything else? 0, because you got the m by itself. All right. Now start slashing. What can I cancel? M minus 3, gone. M plus 2. M minus 2. Anything else? 1M. What am I left with? There you go. Okay. Number 2, B, 3, A, and C. I want to do this one more question, but then that'll be it. And that question won't take that long. All right, 2B, 3A, and C, please. Question of the day. Really big, really ugly, but what is your first step every single time? Factor. So we're going to break this up. We're going to assign it to people because Max is so good at factoring. Max is going to factor this bit. Max is factoring that. $380, yeah. Okay, Max, just the bottom. I just want you to factor the bottom. Who wants to factor this? All right. Who wants to factor this one? Okay, do that. Multiple people do it. There's Aiden, a bunch of people. Does anybody want to do this one? No? You want me to do it? You want to do it? Perfect. All right. Go. This one? I don't think it'll be the easiest. It'll be the longest. You can pull out a 3, but you're still gonna have to do the multiply the first and last and go boom, boom, boom.
I'm done.
No, you're not.
I am. I am. Go back to your other question. A minus 5, 2A plus.
Okay, let me hang on. Yeah, if you want to, you can. There we go.
Two. Wait. Oh, the 2. Oh, yeah.
You fixing it?
2A minus 1. A. Oh,
Did I make a mistake?
I think so.
I can check my work.
Yeah.
Because here's the answers. 2A minus 1, A plus 5. No, that's right.
2A squared plus 10A. Oh, so you have the 2A squared. Yeah. Minus.
Oh yeah. Nothing is go.
Plus 5.
Only that she's good job.
Yeah. All right, is that what people got through factoring?
Oh, yeah, that's what I got.
What multiplies to 15 and adds to 8, 5, and 3?
Yeah.
I can pull an a out of here and get a times 1 minus 2a squared. Hold that, because we're going to talk about that for a sec. This thing here is this one, so I pulled a 3 out, then multiplied the first and the last, factored it, got 3 times 2a plus 1, a plus 3. This one, 2 times negative 5 is negative 10, has to add to 9, so 10 negative 1. Break it up, 2a minus 1, a plus 5.
It's a lot of stuff.
We're not even done yet.
I don't know if it's right, it's just the first thing I saw, on the top right, when you take out just an A, wouldn't the 4A?
Oh, it should be a 4. Thank you. Yeah. I'm just testing you. Where? Oh, that's a 2. There you go. Okay. Is everybody there? Okay. There's one last thing we can do. This thing, when you see two terms separated by a subtraction sign.
Is that difference of square?
Yes, it is. You ask yourself, can you square root both terms? And you can. So we can do it at the end though. Okay? So, right now, write down all your NPVs. First step, NPVs. What are they? 0. 0 is not an NPV. What makes this bracket 0? What makes this one 0? Negative 5. What makes this 0? Yes. 1/2 for that one, or negative, yeah. Negative 1/2 for that one, negative 1/2 for that one. There's your NPVs. Now start slashing stuff. A plus 5, a plus 5, a plus 3, a plus 3. Oops. Okay. Now, this is where this not being factored all the way shows up. That is a difference of squares. So I can square root 1 to get 1. I can square root 4 to get 2, and I can square root a to get a. So that bit becomes there's computers that are, but not calculators. Not very good computers. All right. So what cancels? One plus 2a and 2a plus 1 are the same thing, right? Is that it? How do they cancel? Those aren't the same. But what do you notice? What do you do when they're very similar? Pull out a negative 1. So this one, I can go pull out a negative, and it becomes 2a minus 1, not plus 1. 2a minus 1. And then they cancel. So your answer is negative a over 3. Or, if you want, negative 1/3 a. That is awesome.
It was unnecessary.
That's good. It's goodness.
No.
Mathematical goodness.
It's the exact same as all that.
It is the exact same as all the others. That's why these questions are pretty.
It's just unnecessary.
Why is it unnecessary?
It's too long.
It's just,
Yeah, we got the point.
you got the point? I would like you to do question numero 4A and B, and that's it. The second one will be more like that. The first A is pretty straightforward.